Okay, so today's class is measures of central tendency, and we'll cover three, mode, median, and mean, and I'll walk through the calculation of each. There's also a companion video available on Blackboard and under our week's material covering the topic. So the mode, median, and mean. Why do we need descriptive statistics? As we said last week with frequency distributions, we want something that'll tell us the roughly how well generally did people do, or what do the scores look like generally in terms of central tendency. So generally, on average, how do people do? And we'll also want to look at dispersion and the spread of the scores. Today's focus is on central tendency. And we have three measures of central tendency: the mean, median, and mode. And we will go through each of them. The mode is the most frequently occurring response. The median is rank-based. So it goes through and you'll basically find where the halfway value is. 50% of the people score below the median value, 50% above. And the mean has properties such that it's almost got geometric properties. So if each value is equal weight, the distribution of the values on a number line, the mean will be the balancing point if each value is of equal weight. And we'll go through that in a sec. Okay, so I can see here in this distribution, I have a frequency distribution of people by age, and I want the mode or modal response or modal age. And in this case, the most frequently occurring age is 21. I have 6 people at age 21, and that's the most frequent age. Therefore, 21 is the mode or modal response, or age. The median is the 50th percentile. Half the scores are below that value, half the scores are above. The calculation gets a little funny if you because you have to go by the rank. So whatever the middle rank is, that will be the median value. But sometimes there actually is no specific value at that middle rank, and we have to make an adjustment. So in this way, I have age, and I have the values sorted from youngest to oldest. This is just a respondent code. I number each person as I enter the data into my data file. Here is the rank order. So the person who's youngest is ranked first, and the person who's age 81 and is the oldest is ranked 11. In this case, I have an odd number of cases. So to do this calculation, I need to find the rank of, that's the middle rank. I have 11 people. The 6th rank is the rank that holds the median age. I have 5 people below and 5 people above. So I take, and the formula basically is the number of cases plus 1 divided by 2 will tell me the rank. So in this case, in terms of my ranks, I take I have 11 cases, 11 plus 1, and I will divide that by 2. So once again, that's 11 plus 1 divided by 2 equals 12 divided by 2 equals 6. So for the rank that holds the median age is rank 6. I find that person, and here it is right here. So that's rank 6. I go over, and the median age is 36. Fairly straightforward. Things get a little trickier if I have an even number of cases. This way, I have 5. The 5 youngest are ranked 1 to 5, and the 5 oldest are ranked 6 to 10. So I don't have a specific median age. So the median is basically between the first block of 5 and the second block of 5. So in this case, I need two ranks. I need rank n plus 2, or n divided by 2. So I take 10 divided by 2. I need rank 5. And then n divided by 2 plus 1, which is 10 plus 1. Oh, plus n divided by 2 plus 1, which is 10 divided by 2 is 5. 5 plus 1 is 6. So I need rank 5 and 6. The median value will be the average of those two values. So I'll just I'll put it up here. Oh, let me clear my screen. That's interesting. Okay. So I need to take the rank. I need to take 35 plus 36 divided by 2 equals 71 divided by 2 equals 35.5. Therefore, my median age is 35. Have some practice here. I have the answers on the left right-hand side here. Calculate it on your own and figure it out. So you can go through the answers on the side, and if you struggle to get it right, just walk through the steps as I have them there. Okay, the mean represents the balancing point of your distribution, and I'm going to walk through what I mean by that. So you're probably aware the mean is the sum of the values divided by n. Okay, so what do I mean by this? Okay, so let's have some fun. Okay, so I'm gonna just draw a number line, and let's put values of 6, 5, 4, 7, 8, and 9. So if I have a value of 5, I'll put it here on the number line. It's basically a block, and I have a value of 7. Let's put 3 down here just to be even. If these two blocks here are of the same weight, the block at 5 and the block at 6, the balance point, if I were to balance this on my finger, it would balance on 6. Oopsie, my not good with drawing. Okay, let's I'll leave it. Oh, I can undo here. Okay, let's put my 3 back. Let's see if I can draw a better triangle. Getting better. Okay, so if I take m equals the sum of x over n, which in this case is equal to 5 plus 7 divided by 2 equals 12 divided by 2 equals 6. Now, if I put a value now down here, it's all, once again, each of these values is of the same physical weight. And I put a value up here at 9, have I changed my equilibrium? No. So if I do, I got 3 plus 5 plus 7 plus 9. If I sum those up, so 3, 5, 7, and 9, 8. So it's 16 plus 8 is 24. So m equals sum of x over n, which will equal, in this case, 24 divided by 4 equals 6. Okay, if I were to put a value at 6, would my balance change? No. So physically the balance would stay the same. So I would take 24 plus 6, which is equal to 30, divide by 5 equals 6. So the mean does not change. So the key thing here is the mean is kind of like a balance point. Okay. I just have a couple of examples of the mean. Here's a practice question. Calculate the mean and median for the following sample. I'll do this in Excel and post it on Blackboard. This is an example of just a little kind of like this kind of a question you'll get on a quiz. So I have a mean of 20 with 9 subjects, and I want to add an additional person. So it plays with the notion of the relationship between M and the. So let's see here. That's clear. Drawings. Okay, so if I know M equals the sum of X over N, if I multiply both sides by N, my two N's cancel out, and I'm left with M times N equals the sum of X. So if I know what the mean is and I know what the N is, I can figure out what the value of the sum of X is. So in this case, 20 times by 9 equals 180. So the sum of X is equal to Mn. So once I know that and I have the sum of X, I can start, I can fiddle around with my values. So I'll just clear this out. Okay. So if I want to add a 40, I would just take my sum of X, which I've calculated, add the new score of 40, and add 1 to my N. So 180 plus 40 is 220. N plus 9 plus 1 is 10. 220 divided by 10 is equal to 22. So my new mean is 22. Similarly, I can remove a value. It's the same formula, it's just a little different. I still calculate the sum of X, but now instead of adding a score, I'm removing a score. And since my sample size is decreasing 1, I take my sample size, which in this case was 11, and subtract 1 to make it 10, and walk through the calculations. So if I have a mean of 154 from a sample of 11 people, and I want to remove a person who has X equal to 100, I can do that. So I figure out the sum of X, 154 times by 11, equals 1,694. I take that 1,694, subtract the score I want to remove, which is 100. And I'm taking one person out, so my sample size is not 11, it's now 10. 11 minus 1. And by taking out that score of 100, when the mean was 154, my new mean is 159.4. And that's the end of the show for today. I'll post some examples on Blackboard for you to work through, and I'll do some Excel work.